So 6.5. A 10 to the 5 gigabecquerel source emitting 1 photon per transformation is uniformly distributed along a straight line of 2 meters in length entirely within a water medium. A point 1 meter from the line along a perpendicular to the center of the line. Evaluate the quantities called for in parts A through D of problem. This is problem 1, but I think it's going to end up being the same things. So now you have to use calculus. You can't cheat like last time. So here's point P. Here's our source. It's going to have some line strength emitting photons. We're in water. This is a height of 2 meters. This is along the midpoint, and this is 1 meter. Okay. So we're going to find flux, uncollided flux, uncollided Kerma rate, uncollided Kerma rate air, and exposure rate, uncollided, always for air. So, I just broke this one down into saying that I'm saying that this is by definition equal to this plus this. 1 meter, 1 meter, 1 meter, 1 meter, SL, SL. Everyone okay with that? Which is equal to 2 times this, half math. So, more fun calculus. So, we're going to take a differential length here, and we're going to find the differential flux that comes in through here. So, our d phi is going to equal our SL dx. We're going to have some geometric attenuation, right? Yes. And that is going to be 4 pi times r squared. So let's say that this is big R. I'm going to say that this is our variable height. I'm going to call this dh instead. Sorry. And it's going to be 1 squared or 1 meter length. Length squared plus h squared is going to equal r squared. Everyone okay with leaving the squared off? So this will be our geometric term, and we'll have our exponential attenuation e to the negative mu r, which r is equal to the square root of h squared plus l squared. Okay, so we can make our lives easier by putting things in terms of theta. So we're going to. So I'm going to say that switching my units around myself. So I make a tangent relationship where this is theta. So tangent of theta is equal to h over L. So h is equal to L tan theta, and dh is going to equal, oh boy, done trigonomic stuff. Yeah, it's a 2. Sorry, are you guys used to seeing this? Or is it okay for me to put it on the inside? Okay, I want to do that because that's how I like it. So we're going to go from theta equals 0 2 theta equals something. Theta. That's that value.
Is it dh equals h times secant squared, or is that
L.
L?
L.
Thanks.
I'm using different notation in my notes. So plugging this back in, I'm going to go ahead and integrate that out real quick. So 0 to theta naught, SL, and I'm going to plug stuff in. So dH is going to equal L secant squared theta d theta. 4 pi times some stuff in there. 4 pi L squared, that's constant, plus L squared tangent squared theta, because h squared, we have to square this, and e to the negative mu, and r is going to be some value in here. We have to get r in terms of h. So we're going to use cosine. We're going to say that cosine theta is equal to h over r. So originally we had, don't even need to do that. This is the same as e to the negative mu r, right? So just plug this r into here, saying that r is equal to h over cosine theta. And plug that into here. Okay. Integrating that out. We get something.
Now, do you accept us to use, like, we write our own numerical integration routines or whatever to get?
If you explain it and I can tell you know what you're doing, I'll give you points to get the right answer. But if somebody writes it and other people do the same thing and I can tell they don't know what's going on, so
Don't you also have to plug something in for each?
this is not.
Yeah,
not right.
yep. Well, you can just plug in L
This is
L
not
tangent.
H. I'm sorry.
Oh, well, that makes
Yell
a
at me,
difference.
people. You have to yell at me. I'm using different notation. Cosine, adjacent over hypotenuse. Now, this is a constant. We can pull it out. It's okay. Okay. So now we get that phi is equal to SL over 2 pi L. I have some big F here, theta naught to mu H. Why do I have that? Because this guess what? It cancels out. If you pull L out front. If you factor out this L,
Oh, one
and this
plus.
becomes 1, trig infinity, this is equal to 1. So let me rewrite that so it's not horrible. Okay, everybody okay with what I did here? I just said that secant squared theta over 1 plus tangent squared theta is equal to 1. Trig infinity. It goes away. So everything else is constant except for our exponential term, which happens to be some fancy thing that we don't have to solve because other people solve it. So phi is equal to SL, the length over length squared, 4 pi integral from 0 to theta naught of E negative mu L over cosine theta d theta. Is that right? Yes. One of these L's cancels, goes away. So then I say, and then I recognize that this is some special function that you shield utility solves for. I think that this is some really hard thing to solve or something. Is that what you're asking about, Josiah?
Yeah, well, I mean, it's tabulated in the back too. It's
Yeah.
called a secant integral, so.
Okay, or Sievert integral?
Secant, cause it's got secant.
Secant
it's
integral,
one
okay.
cosine
Alright.
secant, so it's good.
Alright.
Exponential.
Sweet. So, yeah, I'm not big on math, so I'm not gonna solve that. So I have shield util solve that. And you get phi is equal to 2.939 times 10 to the 5 per centimeter squared per second. And now the hard part is over. Because then you just do the exact same thing that you did on the previous problem. You might have any questions on this? Welcome to Dr. Schultz's class. You get to do all kinds of fun stuff again. Anybody have any questions in this? Okay.